This lesson we're going to simplify radicals that are perfect squares and perfect cubes. The first one we're going to look at are perfect squares. So just looking at this, an expression that contains a radical sign, it's called a radical expression. And the expression within or under, such as a here and a here, is called the radicand. So to find the square root of a number, a, we find a number that was squared to get a. So for example, when we look at our list of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, when we square them, we end up getting these perfect squares listed below. Same thing with 11 through 20. These numbers here are perfect squares. I would suggest that you memorize them so that you can easily identify them. You can take the square root of any number above. For example, if I had the square root of 144, then my answer will be 12, because 12 is what we squared to get that square root, or the radicand. All right, we can also take the square root of any variable raised to an even power, such as the list here. So any of these, what we'll do is we'll divide, since we're dealing with square roots, we'll divide 2 into the exponents to simplify. So looking at our examples here, the square root of 25 will be 5, because if you look at your list, 5 squared is 25. That's the radicand. Now we typically, when you get to college algebra, would have to put a plus or minus in front of it, but we're just going to deal with the positive of this. Square root of 225 is 15. The square root of x to the 6th, we're going to divide 2 into the exponent to get x to the 3rd. Divide 2 into 14 gets us x to the 7th. We divide 2 into 10, gives us x to the 5th. And here we can split. This is saying the square root of 16 and the square root of y squared. So the square root of 16 is 4. The square root of y squared is 2 will go into 2 one time, so it's y. So our answer is 4y. When we have a square root under a radical, it's the same thing as saying the square root of the top number over the square root of the bottom number, which will be 6 over 7. And then square roots, though, whenever you square numbers, your number that you square will never be negative. So we can't have the square root of a negative. So this is just not real. Now, college algebra, we'll talk about this as a complex number, which would actually be 5i as the answer. All right, perfect cubes or cube roots is taking the numbers now and cubing them. I would recommend and suggest that you learn the first 5, maybe even the first 6. The rest of these, we very rarely encounter in intermediate. But you can also take the cube root of any of the numbers. Be careful, because some of our numbers, like 64, is a perfect cube and it is a perfect square. To simplify cubes, we have variables. Our variables have to be, or exponents are multiples of 3, like 3, 6, 9, 12, 15, and so on. So for these examples, the cube root of 27, what number, when we cube it, will be 27? We'll look at the list, or you memorize it. The cube root of 27 is 3. The cube root of negative 64. Now with the square root, we can't have this negative, but cube roots we can. Cube root of 64 is 4, but since it's negative, it will be negative 4. The cube root of 216 is 6. Now what we'll do is divide this 3 into 15. It goes 5 times evenly. And then we're going to divide 3 into 12, and it goes 4 times even.